My name is Terrie Simmons-Ehrhardt, and today I'll be presenting on Doe3D, an effort to facilitate 3D digitization of unidentified cases in the U.S. Just a quick note that this presentation contains 3D scanned images of animal bones and textureless 3D CT models of human bones generated from public repositories, and there are no images of actual human remains or actual forensic cases. I'd like to just give a little background on myself to explain sort of the trajectory of my experience in forensic anthropology that has led me to this effort. My background and skills in forensic anthropology have always involved 3D technology, whether processing and analyzing CT scans for facial approximation research, 3D scanning of skulls for facial approximation, photogrammetry, 3D printing, 3D web display, and also most recently participating in the validation of the Skeleton ID Craniofacial Superimposition software, which was presented earlier this week. I've reached the point that I have the experience and technological resources to get this effort started. So now the goal is to put it out there and to find collaborators who can help make this happen. So what is Doe3D? Doe3D is a website that I set up to provide imaging resources to help bridge the gap between unidentified case custodians and imaging specialists. What are these gaps, and why is there a gap or a disconnect between unidentified case custodians and imaging specialists? For the most part, in the US, imaging specialists are not employed within law enforcement agencies or medical examiner and coroner offices, so they tend to work independently. Secondly, there are many subspecialties among imaging specialists. These individuals can perform facial approximation. They might specialize in photography, postmortem facial touch-ups, imaging and touch-ups of personal effects, 3D surface scanning, biomedical imaging, or biomedical image processing, or some combination of these skills. There's no one person that can do all of those things. And so it requires, it requires a team effort to sort of fulfill these specialties. One of the gaps is that there are no imaging guidelines for skeletal remains or even for facial applications. And there's such a wide range of imaging tools that can be used, but there's no recommendations and no protocols. So just because you have a 3D scanner doesn't mean you're capturing the features well, or the features needed, for example, for facial approximation or craniofacial superimposition. Secondly, although some artists generate 3D facial approximations, either clay or sculpted digitally, they're not displayed on the web in 3D, despite the fact that it's quite easy to display 3D models on the web. So there's this so there's less interaction potential with the public when they're viewing just screenshots of facial approximations, even though they were generated in 3D. And third, despite all of the research in forensic anthropology utilizing 3D technology, there's been no systematic effort to digitize skeletal remains. And this conference this week illustrates a range of 3D technology that can assist with unidentified cases, but this technology can't be applied to unidentified cases unless the remains are digitized and ready for the application of these methods. The idea behind Doe3D is to encourage more systematic digitization of remains for preservation, for one thing, because remains can become damaged, lost, buried, or cremated. I have certainly scanned remains that had at one point had teeth, but eventually by the time I got to scanning them, they lost their teeth or the dentition had been cut out for dental imaging, and this means that the remains required reassembly before facial approximation could take place. The website would also offer imaging guidelines once we work on developing those. lists of imaging specialists and their services, web hosting of 3D facial approximations, and facilitating digital transmission of media, images and videos, 3D models, whatever, to case custodians and other forensic professionals as needed. The image on this slide is showing a screenshot of NamUs, the National Missing and Unidentified Database for the US. And you can see from those cases there that there are no images. Those are recent cases, so there's no images have been generated yet, and hopefully they will be and added to the case profiles. While Doe3D is currently focused on cases in the US, the ideas and the guidelines and services can be translated to other countries as well. And in fact, a lot of the work on these 3D identification methods, especially craniofacial methods, have actually been done outside of the US. So a lot of these guidelines and protocols are going to be based on what has already been produced. So what am I talking about when I say 3D digitization? Basically, 3D scanning, or the generation of a digital twin of unidentified decedents, whether it's skeletal or fleshed, and or personal effects, such as clothing and jewelry, using modern imaging technology. The idea is to create a quantitatively and morphologically accurate digital copy of cases that can be analyzed and transmitted if needed, or from which images and videos can be generated to enhance case profiles. In the next few slides, I'll quickly discuss the types of digitization we can apply: external surface capture and transmissive capture. External surface capture refers to what we normally think of when we talk about digitization or 3D scanning. This includes light-based surface scanning, photogrammetry, and mobile photogrammetry. Surface scanning requires a device that projects lasers or structured light onto the surface of an object to capture the geometry and reconstruct it into a 3D model. Most of these have some color capture capabilities, but they tend to be lower resolution than what you can capture with a camera. So the color tends to not be photorealistic. However, these are likely the most geometrically accurate and probably capable of capturing the most detail, at least for external surface capture. I know a bunch of us had kind of started with the Next Engine scanner, which was, very affordable, even with the software. Because the company is gone, the starting price of surface scanners now is around 10,000, 8 to 10K, and then it goes much higher up from there. And you also have to purchase the software that goes with the scanner as well to process your scans, so it can get pretty pricey. Photogrammetry involves taking a series of photos around an object and then constructing a 3D model from those photos. So you would use a digital camera and software so that you can achieve a photorealistic 3D model. But more research is needed to investigate the amount of detail of the geometry and the optimal workflows for different skeletal elements. Photogrammetry is less expensive than surface scanning, only requiring a camera, a software license, and a computer. For the software, the primary options are Agisoft Metashape, which has several different license options, Reality Capture, which offers per scan payment, but also educational discounts or options, and the Mushroom software, which is free. For now, the most comprehensive protocol we have for photogrammetry, at least for skulls, is located on the Panacea Cooperative Research website, which I have on this slide. Another photogrammetry option that we have now is mobile photogrammetry apps. iPhones, iPads, and Android devices for some applications have apps that allow a user to take photos, usually 200, some up to 300, and process them in the cloud with different settings to get a 3D model. With the camera resolutions of mobile devices, high-quality photorealistic models can be achieved, much easier than using the photogrammetry software mentioned in the previous slide. Mobile photogrammetry is certainly the least expensive and most accessible, since most of us have smartphones or tablets capable of running these applications. More research is needed to evaluate the workflows and outputs, especially the amount of detail and geometry that can be captured. Some considerations before using these apps more widely is data privacy. What types of privacy settings does the app offer? Some apps have a social sharing aspect, so you would have to make sure that your secure scans are not sent to the social feed. What types of file formats can you export, and to what destinations? Can you send them to a Dropbox or just to save them locally, etc.? Do you have access to the raw data? So in some apps, you can take the photos outside of the app and then import them in for processing, but most of the apps require you to take the photos inside of the app. So ideally, we would want to have access to those raw images so you can take them out or have them for documentation, and especially as we're doing research and comparing, we want to have access to those images as well. Does the app have object masking? Meaning, are you able to flip the bone over that you're scanning in order to make a 360-degree capture? And what kind of post-processing, if any, will you have to apply? Are you going to get a final, finished, clean model, or are you going to have to export to some other software to clean up the scan? Ultimately, the goal would be to have a mobile app that is specific for scanning skeletal remains and or faces for unidentified decedents that have facial tissue, or to evaluate these to the point that we can develop protocols so that agencies that have remains can collect the appropriate photos that are needed and send them to Doe3D or Doe3D associated imaging specialists who can process them into a 3D model. Transmissive capture includes biomedical imaging, or computed tomography, micro CT, and cone beam CT. So you have X-ray beams penetrating the object to capture both external and internal surfaces, although without color. For remains with adhering soft tissue, transmissive capture would allow for the soft tissue to be digitally removed using CT software. And this is great. However, this would be the least accessible option because it would require cooperation with the biomedical imaging lab. The ideal solution then would be to have external surface capture that is photorealistic because that captures things that we would not be able to see in a CT scan. But to combine this with high resolution transmissive capture, whether it's CT, micro CT, cone beam CT, so to have a full capture of the remains would require both of these imaging techniques. So what can we do with these skeletal remains once they're digitized? What are some of the immediate things that we can generate to help enhance case profiles? In the case of crania, we can prepare the skull for craniofacial identification, which includes facial approximation and or craniofacial superimposition. Once in a 3D digital format, a skull can be digitally repaired if it's damaged or missing parts using 3D software such as Blender or MeshLab. It can be set into Frankfurt horizontal alignment for whether a facial approximation practitioner works in 2D or 3D, and the images or 3D models can also be sent. It can also be 3D printed, and the 3D printed model could be sent out for facial approximation. The 3D model can also be used in the skeleton ID software, which was presented earlier this week for craniofacial superimposition, to use the AI-based comparison of the skull to missing person photos. New media can be generated from 3D digital models if potentially identifying information could enhance a case profile, such as unique dentition. Currently, there are some images of actual skeletal remains on NamUs, and these aren't really appropriate for public display. Even if we have a photorealistic 3D model, the texture can be turned off to generate a solid color model and to generate cleaner images of the dentition if it's needed. By digitizing personal effects, if possible, 3D body representations can also be generated to display clothing, jewelry, and tattoos. As you can see from the thumbnails in the NamUs screenshot, some cases have no images at all. So not even of personal effects, just nothing. One of the things that Doe3D offers is web hosting of 3D facial approximations and 3D body models. Beyond screenshots, the public doesn't have an opportunity to actually interact with the facial approximations. The models would be publicly visible, but not downloadable. The 3D viewers can be embedded in an agency website, or a link can be included in the NamUs profile. This video is showing a mock facial approximation, just a face that I generated in Make Human and Blender. And you can follow the link to interact with the 3D face model and see what this would look like for the public. So down to specifics and what you can do. If you are a case custodian, you can request imaging services, 3D scanning of skeletal remains, including the repair, cleanup, generation of images, videos, 3D models, 3D prints, facial approximation consultations, web hosting of 3D facial approximations if you already have some, processing of CT scans, information on facial approximation practitioners. There are forums on the website to request services or to just place general inquiries. There's also a forum for imaging specialists to request listing on the site along with the services you offer. If you are a facial approximation practitioner, you can request to have web hosting of your 3D facial approximations or even 3D scanning of your clay facial approximations so that they can be hosted on the web in 3D. There's also opportunities to collaborate on imaging research, as mentioned before. If you're not interested in receiving imaging services, or you're not necessarily an imaging specialist, but you're interested and want to be involved, there's certainly a need to evaluate the variety of imaging tools that are available to develop best practices and to determine which apps or tools or software are the most likely to provide the features that are needed. And I just want to say thank you so much and for listening. And please feel free to reach out to me at Doe3D, at my website, or on social media. Thank you.